Your area depends on two things, doesn't it? It depends on x and y. We need to get it to a single variable so we can do the calculus. So now we need a constraint. The constraint here is what? Is it the same constraint as last time or no? Isn't it different? How much fence do you use to build that piece? How much of your 100 feet are you going to use to build this? Well, what are we calling this distance? X, right? How much are you going to use to build that? X. How much to build this? How about that up there? How about that? How about that? How many x's is that? 6 x's, right? When you put your 6 x's together with, how many y's are you going to need? You're going to need 4 y's, aren't you? 6 x's along with 4 y's has to add up to be the 100 feet of fence. See, it's not a perimeter anymore because I've got these partitions in the middle, right? So what I know is that 6 x's plus 4 y's has to be 100 feet of fence. That's my constraint. See, it's a little more complicated when it's not a rectangle because you got these little pieces in the middle to worry about. I can do the same thing I did a second ago. I can solve that for y and come back and plug it in over here. That's what I'm going to do now. So I'm going to first move the 6x to the other side by subtracting it. Then I'm going to divide by 4. 100 divided by 4 is 25. And 6 divided by 4 is 3 halves, right? Because when you divide 6 by 4, you can reduce that fraction to 3 over 2. Any questions here? Take this and plug it in over there. So the area equals 3x times y, but y turns out to be 25 minus 3 over 2x, or 3 halves x. Let's distribute the 3x through. And I'm also realizing now that the area is a function of a single variable now, right? So when I distribute here, I get 75x. When I distribute here to here, I get minus, and that's going to be 9 over 2x squared. Sorry, almost forgot the squared. Right, because when you multiply 3 times 3 halves, that fraction you just multiply straight across. It's like 3 over 1 over 3 over, 3 over 1 times 3 over 2. And then the negative comes with us, square the x. Any questions there? Does it make sense? It's a function of a single variable now, right? Yes?
So we always have to have a single variable?
Yes. In Cal 1, yes. Yep, we cannot find the maximum of a function of 2 variables. Yeah. It's more complicated. But it actually turns out to be easy. In Cal 3, we realize, oh, we can go back and do all these problems that we did here. We can do them in Cal 3 pretty easily. All right, good? What now? What is that? Domain. So this is where we're determining whether or not we're going to do the closed interval method or the open interval method. So can you give me some ideas on any restrictions I have on x? Like what, again, is the smallest value of x I could have? What's the smallest this could be? 0, and then again, you're not really building any enclosures, right? But that's like the absolute extreme, 0. All right, this is the one that gets people. What about the biggest it can be? Well, how many x's would you have to have? Well, how many x's did we say we had here? 6 of them. So you could use all of your fence for just the x's, couldn't you? What number is that?
50 over 3.
50 over 3. So you're taking the 100 and you're dividing it by 6, right? You're saying I have 100 feet, I'm going to use it for all 6 of these pieces. So that's 100 divided by 6, which is 50 thirds, or 50 over 3. right? That comes from taking the 100 feet of fence and dividing it by the six pieces that I would need for x, and then reducing the fraction. All right, closed interval method. Let's do it. So this is going to be closed interval method. So we're going to take the derivative. The derivative of this function is 75 minus 9x, right? Derivative of this 75, then here the 2 comes out and the 2 and the half cancel. You're left with the 9 that's in front, and then you have x. Yes?
So I just wanted to confirm something.
Uh-huh.
You know how we're doing x, is that the reason why you're using the domain of x specifically and not y?
Yes. Yeah, good question. So we've turned this into a function of x, haven't we? So when we're looking at domain, we're saying what are our restrictions on x, not y. Had we done y, then the restriction on y would be 0 to, let's see, we would need 1, 2, 3, 4 of them. So 100 divided by 4 would be 25. 0 to 25. Yep. All right. Take the derivative of this, right? We're going to do this thing, critical numbers. Where's the derivative 0? Where's the derivative not exist? Let me just throw this out right now. Does not exist doesn't matter because that's nice, right? Set that to 0. And 75 equals 9x. And divide both sides by 9. And you get x. Now maybe you need to go and put that in your calculator, but you can check that this number does live in here. Okay? What is 50 divided by 3 as a decimal? What is it, 16.67, so 16.666, 16.6, whatever, close enough. And then this right here, do that on your calculator, please. What is it? 8.3? 3? Repeated? Okay, 8.3 repeated. All right, so that lives in here, right? All right, good? Are we done? No, we have to verify that that's a max. So we're going to verify it. So what we're going to do now is we're going to take the original function a, we're going to plug in 0, the original function a, and we're going to plug in 50 over 3. That's the two endpoints. And then a, and then plug in 75 over 9. Now, I already know that I'll get 0 here and 0 here. How do I know I'm going to get 0 here and 0 here? Because those were those extremes, right? I already knew that, like this one, I'm letting x be 0. I'm not going to have any area. And if I take the other extreme, that means I'm using x for all the fence. I don't have anything left for y, so I should have no area. This one has got to be the max. Plugging it in, though, is going to be a little bit of a pain in the butt. Let me try it. I'm plugging it into this. It's 75 times 75 over 9. Minus 9 over 2 times 75 squared. Does anyone have that yet? Give it as a decimal. It's a number, right? It's bigger than 0. Am I interested in this number? Other than the fact that it's positive, I mean that it's bigger than those, do I really care about the number to answer the question? No, because I'm asking for the dimensions, right? What are the dimensions? Anyone have it yet or no? No, or are y'all not going to do it? So what I'm going to do is I'm going to cheat here. $312.5. Square feet, right? That's definitely the max. All right, let's answer the question now. Do you have a question? Yeah.
Maybe I'm just missing something, but at the very end, when you plug in x or it's squared, why is the 9?
Oh, I'm missing a 9. That's what it is. Yeah, I'm missing a 9.
Okay, I'm missing.
Thank you. I've had a remarkable week of making stupid mistakes like that, or like leaving things out. I've set a new standard, a low standard for myself this week.
So is the answer right?
The answer's right. The answer's right. I apologize. All right, so let's answer the question. What are the dimensions? So I know that I get a maximum when x is that number, 75 over 9, which we said is 8.33. So 8.3 repeated feet, right? That's how long x needs to be. That's this number here, right? And then the y value, the y is actually, go back to the constraint. I've erased the constraint. Do you remember we had solved for y? What was y back in the day? 25 minus 3 over 2x. So we've got to figure out what that is. So 25 minus, do this on the calculator, 3 over 2 is 1.5. Multiply that times 8.3. And that'll give us an approximate answer. Just replacing the x with 8.3. Anybody have it? What is it? 12.45? Yep, 12.45. Close enough. There you go.
Do you want us to get the decimal for these answers?
You can do the exact answer as a fraction, that's fine, or you could do decimal. I don't care. Either one. The leaving it as a fraction is what we call the exact answer, and that's preferred, but sometimes we just don't want to mess with fractions, so we just go to the calculator. All right, understand? Getting the basic idea of these? The big thing is you need to somehow write your objective, some constraint, turn your objective into a function of a single variable, determine if it's a closed interval or open interval, and then do the calculus and get your answer. I'm going to put another problem up here, okay? And then I'm going to step out for just a minute. And then when I come back, let's see what y'all think, all right? So we wish to build an enclosure as shown below, all right? I'm going to draw you another picture. And I'm going to change the wording of the rest of the problem. You want an area to be 100 square feet. Okay? That's different, right? I'm not giving you 100 feet of fence. I'm saying you need to build this thing so that it has 100 square feet of area total. Right? That's not the length, it's the area inside. Find the dimensions which, what do you think I'm going to say? What do you think I'm going to ask you for? That was minimizes the amount of fence. I want you to build me an enclosure that gives you the area of 100, but will minimize the amount of fence required to do it. Which minimizes the fence needed. Let me kind of give you an idea just of what how this problem differs from what we had before. Do you agree that this enclosure right here, 100 feet by 1 foot, do you agree that that has an area of 100? Area of 100, yes? But how much fence did I need to build that? I needed 200, 100 here, 100 here. I need 200 plus 1 plus 1. I needed 202 feet of fence to build that, didn't I? I could have done this, though. Right? So this right here required 202 feet of fence, right? This has an area of 100 also, right? How much fence do I need for this? 25, 25, 50, plus 4 and 4, 58. So what's better? I mean, okay, for this it would be a square, right? For this it would be a square. But do you get the idea? I mean, there's a big difference, this cost of materials, right? So I haven't drawn the picture yet. Here's the picture I want. Here's what I want you to build me. Let's build our enclosure like this. Just like that. So those are equivalent sized pens for my dogs. I need a total area of 100 square feet, but I want it built in a way that I use the least amount of fence. Got it? See if you can get this thing set up. All right? Objective, see if you can come up with a constraint, talk to each other, help each other out. I'll be back in just a moment. Progress or no? No? Huh? Have y'all labeled the thing yet? Let's start with that. Did y'all do it the same way I did the last one? There's multiple ways to do this. So did y'all call this side X right here? So from here to here is X. And then from here to here is Y. That okay? Everyone on that same page there? What's the objective? What are we trying to either maximize or minimize? The perimeter, or the total fence used, right? For us, we'll call it P for perimeter, even though it's not technically a perimeter. Yes? So the objective, right? The objective is the P, the perimeter. Now, can you tell me what the perimeter is, or the fence that we would need to build this? 4 x's, so 1, 2, 3, 4 x's plus 2 y's. Show of hands, how many of you had that much? Sorry, 3 y's, 3 y's. So nobody had that? 3 y's, yes? How many of you had that part? Yeah? Okay. What's the constraint? Do we have a constraint? Like, can x and y be anything we want? No, we have to live within the constraint of the problem. What is the constraint of the problem? That the area must be what? 100, right? The area has to be 100. That's the constraint. What is the area of that object over there? Be careful here. What's the area of this? Well, how long is this side? 2x, right? Not x squared, 2x, because you're adding x plus x, 2x. And this side is y. So 2x times y is 2xy. So 2xy must be 100. You have any questions? How many of you had that much? A few of you? Okay. What now? Yeah, we need this to be a function of a single variable. Right now my perimeter depends on 2 different variables, but over there I have an equation with 2 different variables. So I'm going to take that one and solve for y. Could I solve for x? Yes, but I think the standard is solve for y. So solve for y, which means you will divide both sides by 2x. Divide, right? Not subtract. And so you get y is 50 over x, right? 50 over x. Take that and plug that back in over here. The perimeter is now 4x plus 3 times y, but that y was 50 over x. Next line, my perimeter is now a function of a single variable x, and it is exactly 4x plus 150 over x. So I just took 50 over x, plugged it in right here, and then I multiplied by 3, so the 3 just hits the 50, becomes 150 over x. There, it's a function of a single variable now, right? Questions there? Everyone following that? All right, what's the next critical step? Which way are we doing this, right? Domain. Like, what is our restriction? Is it a closed interval? Is it an open interval? So let's start with the smallest x can be. What's the smallest that x can be? 0, right? That's what we said in the past, right? 0, but do y'all see why it can't be 0 this time? Why not? What would y have to be if x is 0? If x is 0, what's y? Undefined, right? If you go back to our previous problems, if we let x be 0, y was still defined. Y would have had to have been the rest of the fence. But this time, if x is 0, then y can't be anything because you still have to have 100 as an area. See, we have to have 100 as an area. We have to. So if I say, hey, build me that enclosure and let x be 0, you'll never get an area of 100, ever. Now, could x be 0.0001? Could I make this 0.0001 and then the next one 0.0001? Could I do that? Yeah, but the y would have to be really big, right? And my dog wouldn't fit in there anyway, but that would be possible, wouldn't it? If I put 0.0001 right here, take 50, divide it by that, that's going to give me the y value, right? It'll be huge. So I can do that, but I can't do 0 or else this is undefined, which means I can do everything up to 0 but not including 0, which means this is an open interval, not a closed interval. So my domain here is 0, 2. All right, now what's the biggest x can be? 50? Could I make x 100? Let me see. Could I make x 1,000? Could I do 1,000? 1,000? Right? 1,000, 1,000. Well, just do it here. If x is 1,000, will I have a y value? Take 50 and divide it by 1,000. You get a number, wouldn't you? Small number? But that would mean you have your enclosure would look like this. It would just go up just a tiny bit. Like that. And it would have an area of 100, right? It would still have an area of 100, but it's not really feasible to do that. It doesn't make sense to do that. But there is no restriction on how big x can be. X could be 1,000,000. 50 divided by 1,000,000 is still a number, right? So there's no restriction on the x here. See, there's a big difference between talking about area and perimeter. If I say a perimeter is fixed at 100, then you can't go beyond that, right? When we talk about area, one side could get really small and the other side just has to get really big. And it's a give and a take. We never run out of fence that way because we're not restricting, we're not giving a restriction on the amount of fence here, we're only giving a restriction on the area. Does that make sense to y'all? There's a big difference between those two things. So this is 0 to what? Infinity. And that's an open interval. I'm going to put that underneath here. So now I'm going to use the open interval method. Which is almost like the closed interval method. We still take the derivative. All right, what is the derivative of the p function, which kind of stands for perimeter here? Well, the derivative of 4x is what? 4, that's not a problem. Okay, now this one is the one that's an issue. We have to take derivative of that, don't we? Now you might be thinking quotient rule, fine, but I suggest you look at that as 150 times x to the negative 1. So bring that x up and then take your derivative. What would the derivative of that be? Negative 150 x to the negative 2. That's the derivative of that, right? So it'll be 4 minus 150. I'm going to write that as 150 over x squared. So I'm taking this answer, I'm dropping the x to the negative 2 back down to the denominator to make it look like this. Y'all got this or not? Everyone's good or no? Yeah? Okay. What do I do with that? Set it equal to 0, figure out where it doesn't exist, right? Set it equal to 0, figure out where it doesn't exist. So where is this derivative equal 0? Yeah, we're not doing concave up and down. We only want to know where the graph goes up and down. That's it. So derivative equal to 0. Fun stuff. All right, set this equal to 0. How do we set that equal to 0? What's been our kind of plan of attack on things like that? Common denominator. You could also move the negative. You can move it to the other side. I'm going to do common denominator because that's kind of the theme I've been using. I look at that as 4 over 1, and then I multiply the top and bottom of this by x squared, right? So this becomes 4x squared over x squared minus 150 over x squared equals 0. Now that they have the same denominator, put them together. 4x squared minus 150 over x squared equals 0. And then I'm saying, okay, the only time a fraction can be equal to 0 is if the top is equal to 0. Move the 150 over. Divide by 4. Sorry, I'm trying to squeeze this all in here. 150 divided by 4, that doesn't reduce, but what is that as a, what is this side as a decimal?
37.5.
What is it?
37.
37.5? X squared is 37.5. And now take the square root. X is what? 6.1? Plus or minus, right? Because we took the square root. Plus or minus 6.1. So when I set the derivative equal to 0, I got two solutions, positive 6.1 and negative 6.1. Are they both critical numbers? Both of them? What's our domain? 0 to infinity. So we're only going to look at the positive one, right? So really, our critical number, I'm going to put it right here. X is 6.1. That was me trying to figure out where the derivative was 0, right? I also need to figure out where the derivative doesn't exist. Let me do that over here. Where does this derivative not exist? Does not exist. Anywhere? Here's your derivative. Is there anything I could plug into that would cause a problem? 0. Is 0 in our domain? I erased it. Is 0 in our domain? No, right? Because it was open interval, right? So we're not including 0. So I don't have anything from here. So I would say x equals 0. Yeah, that causes a problem, but I'm throwing it out because it's not in the domain. Not in the domain 0 to infinity. So I only have one critical number, right? What now? Open interval method. Not that into the derivative. Remember I had y'all do this, y'all promised me 3 times we're going to do what? What gets plugged into the derivative? Test points. I need test points. How do I get test points? This is where we draw the number line, right? So I'm going to draw a number line. The only critical number on there is 6.1. I need to pick a point to the left of this. How about 1? I like 1. And then to the right, let me just pick 10. Just remember, you can't go past 0, right? You can't go past 0 because our domain restrictions. Where are those points, those test points getting plugged into? The derivative, right? So what I'm going to do now is I'm going to take the derivative, p prime, and I'm going to plug in 1, and then p prime, and I'm going to plug in 10. And I'm going to see whether or not I get a positive or a negative answer when I do this. So here's your derivative right here. Let's plug 1 into this. What's 150 divided by 1 squared? It's just still 150, right? What's 4 take away 150? Negative, right? That's a negative number. Now plug in 10. What's 150 divided by 10 squared? Well, 10 squared is 100, isn't it? 150 divided by 100 is 1.5. And 4 take away 1.5 is going to give you a positive number. I'm trusting you could plug these in and get the signs of these, but this is positive. So the derivative is negative. What does the derivative being negative tell us about the original function? What is it doing? Going down, and then at 10 it's going